Today's spotlight is on learning targets 7, 8, 11, 12, and 13, which are all about graphing secant and cosecant. Learning targets 7 and 8 are about describing the basic properties of graphs of secant and cosecant. 11, 12, and 13 are about describing the transformations, determining the order they should go in, and actually performing them on the graph. We're going to start off with the secant graph. Secant is the reciprocal of cosine. Since it's the reciprocal, which hopefully you remember from our previous units, you can actually use the cosine curve as your starting graph. So start with the cosine curve. Any place that cosine was 0 is now going to be undefined for secant. The reciprocal of 0 is undefined. And that's going to represent an asymptote on the secant graph. Any place that cosine was positive 1, the reciprocal is 1, and negative 1, the reciprocal is negative 1. So those points are also going to match. We take our original cosine curve in a dashed line, which we'll see happening this whole time that we graph secant and cosecant. We use that to then find our places where cosine was 0 to now represent our asymptotes. So that happens at negative 3 pi over 2, negative pi over 2, pi over 2, and 3 pi over 2. Any place we had a positive 1 is going to stay a positive 1. Any place we had a negative 1 is going to stay a negative 1. So all of those points are still on my graph. Notice I'm using a different color. For you, you'll have dashed versus solid, which is fine. And you're going to arc away from the original sine or cosine curve with approximately the same distance. Any place in between the positive 1 and 0 or negative 1 and 0 is a fraction. And when you take the reciprocal of that fraction, it's going to get bigger. So that's why we are branching away from this curve and toward larger numbers, because the reciprocal of any of those fractions is going to be a whole number. And our graph in blue is our actual secant curve. Cosecant is the reciprocal of sine. So we're going to start instead here with the sine curve. Where sine is 0, cosecant will be undefined because the reciprocal of 0 is undefined. Reciprocal of 1 is 1, negative 1 is negative 1, so those points again match. So this is going to work very much the same way. You start with your original sine curve, so you've got it going through 0, 0 on the upswing. Identify any place where sine was 0 as an asymptote for cosecant. So here it's going to happen at negative 2 pi, negative pi, 0, pi, and 2 pi. So we identify all of those curves, or all of those asymptotes. Any place we had positive 1, it stays positive 1. Any place we had negative 1 is still going to be negative 1. And we branch away from that curve to draw our new cosecant curve. We've got several steps that we're going to follow to actually perform these transformations on the graph. So start off with your secant and cosecant being replaced by their respective reciprocal functions. So if you're thinking about negative 3 secant of x minus pi, instead of thinking about it as secant, you're going to think about it as cosine. So you're going to think about negative 3 cosine of x minus pi instead. Then you're going to use what we've learned in Units 8 and Unit 9 about all the transformations to identify all the transformations that are necessary. Make sure that you're considering reflections, stretches, and shifts all together. So make sure you make a comprehensive list of all the transformations that are happening. Perform the transformations on the original sine or cosine graph. Draw them as dashed lines, seeing as how they are not our answer because we're really trying to graph secant or cosecant. Before you do any vertical shifts at the very end, make sure that you draw in the asymptotes for the zeros. It gets a little tricky when you move those zeros away to identify the asymptotes. So do that before you do the vertical shift. Then use the new min and max values along with the asymptotes and the amplitude to draw secant or cosecant. So mins and maxes, those points are going to stay the same just like they did on the originals. Then you use those asymptotes to help guide you away. Our first example is 3 secant of x. You're going to start off by thinking of it as y equals 3 cosine of x. That 3 out front represents an a value, which should change our amplitude to 3, causing a vertical stretch times 3. Start off with your original cosine curve, drawing in the points, connecting them with a smoothed dashed line. Vertical stretch times 3 is going to move any point at positive 1 to positive 3, any point at negative 1 to negative 3, and any point at 0 is going to stay at 0. 0 times 3 equals 0. Again, draw in the points, connect them with a nice smooth dashed curve. Any place you had a 0 should now be an asymptote. Use the new maxes and the new mins as your starting spot and start reflecting away from. You should be filling the whole screen, negative 2 pi to positive 2 pi, and the blue final answer. Example 2 is a little more complicated because it has multiple parts happening. You've got an a value, a c value, and a d value, which are going to cause 3 different transformations. Start off by thinking about it as its reciprocal function, sine. So we're going to think y equals negative sine of x plus pi over 2. Then think about what transformations those will be. If you read left to right, you should go in the appropriate order. A reflection over the x-axis. Moving left, pi over 2. And moving up 1. I'm going to number those in order. The multiplier has to come first. The reflection has to come first. Left and up can come in any order. So I'm going to make sure that I label that my reflection is first, left pi over 2 is second, and up 1 is third. So that when I go to graph these, I know the order that I'm doing them in. So label each transformation between the graph as 1, 2, or 3. Start off with the original sine curve. Reflecting over the x-axis is going to cause any point on the x-axis to remain on the x-axis. Any point above will now be below. Any point below will now be above. Pi over 2 is 1 unit on our graph, so when we go to move left pi over 2, everything should shift 1 unit to the left. We're just going to move that point from negative 3 pi over 2 over to negative 2 pi, and so on. And here we have a vertical shift. So before we do our vertical shift, we're going to identify our asymptotes. We've got them at negative 3 pi over 2, negative pi over 2, positive pi over 2, and positive 3 pi over 2. Now I translate every point on my graph up 1. And finally use your new maxes and new mins to create the curve for your cosecant graph. The curve in blue is your final answer. On to the final example, example 3. Example 3 has an A, B, C, and D value. Anytime you have B and C, you need to make sure that before you're actually starting to do anything, you factor. Everyone's favorite part of math, factoring. So we're going to think about this as 2 cosine of negative 2 times the quantity of x minus pi over 2 minus 2 at the very end. It's going to cause 5 different transformations. The 2 out front will cause a vertical stretch times 2. The negative inside the party is going to cause a reflection over the y-axis. The 2 as a b value is going to cause a horizontal shrink times 1/2 because we take the reciprocal of b for our stretch or shrink factor. After we factored, we had pi over 2 with subtraction, which meant it's going to move right pi over 2. And at the very end, we had minus 2 for down 2. Start with your original cosine curve. Again, we are using dashed lines so that we know we're not representing any sort of answer. Vertical stretch times 2 is going to cause any point at positive 1 to become positive 2, any point at negative 1 to become negative 2, any point at 0 to remain as 0. Again, connecting with that dashed curved line. Our second transformation is a reflection over the y-axis. However, cosine is an even function, which means it has symmetry over the y-axis, which means that when I do that reflection, I should end up with the exact same graph that I did before. We still use it as a graph on our function. We still use it as a graph so that we can represent that we actually performed that transformation. It's just that it didn't make any difference. Next, we do a horizontal shrink times a half. It's easiest to start in the middle. Any x value of 0 is going to stay 0. So that point at the maximum stays the maximum. At negative pi, you would move over to now negative pi over 4. Negative pi over 2 would now move to negative pi over 4. Negative pi would now be negative pi over 2, and so on. You repeat this all the way across. Connect with a nice smooth curve. Next, I move everything right pi over 2. On our graph, that is 1 unit for x. So everything translates 1 unit to the right for x. Notice that I'm marking all of the maximums at the same time and all of the minimums at the same time. Then I kind of get an idea of where my function is and the patterns of it. All those middles, when you translate pi over 2, are going to just go right back to where another one was to begin with. So it's still all in the pi over 4s across that x-axis. Connect with a nice smooth dashed curve. Our final piece is to move this down 2. Final piece is to move this down 2. But before we do that, we're going to want to make sure that we put in our asymptotes before we do any vertical shifts. I had an asymptote every pi over 4 because I had a 0 every pi over 4. Translate each one of these points down 2. So all those minimums at negative 2 are now at negative 4. All of the maximums that were positive 2 are now at 0. That midline at 0 is now at negative 2. Again, you'll notice I do all of the minimums together, all of the maximums together, so I get an idea of what my pattern is, and then I will connect them. I also forgot to number these, so my order of my list that I went ahead and added in the numbers 1 through 5 for those numbers. Use each one of your new maxes and your new mins to connect the secant curve that you have formed off of that cosine. Notice this goes a bit below the graph. It should be pretty steep because you changed that amplitude to a 2, so it should be moving a little more steeply toward those asymptotes than the original cosine or secant graph would have. That is the final example, and we'll have some time to go over some more practice tomorrow in class if you need it.